How stars become giants. Not all stars are created equal. Some remain small and dim, like red dwarfs, the most common type of star in the universe. Others, like our Sun, burn steadily for billions of years. But sometimes, something much, much bigger is born. Something so massive, it can change the fate of an entire galaxy. A star's size depends on the amount of hydrogen and helium it can pull in during its formation. If a star forms in a region rich in gas, like the heart of a dense nebula, it has the potential to grow to an unimaginable size. But there's a problem. A star is in a constant battle with itself. Gravity, an unstoppable force, tries to crush it, but nuclear fusion pushes outward, creating a delicate balance. The bigger the star, the harder this battle becomes. As stars grow into supergiants, their internal pressure becomes so intense that they start fusing heavier elements: carbon, oxygen, and even iron. But this comes at a cost. The bigger they are, the faster they burn through their fuel, and the more dramatic their deaths will be. From the chaos of collapsing gas and dust, stars are born, but only a few grow into true cosmic giants. Some stars will quietly burn for billions of years, but others, they will expand beyond imagination, becoming the largest stars we've ever discovered. In our next episode, we meet the true titans of the universe, the biggest stars known to science. What makes them so massive? How long can they survive? And what happens when they reach their final moments?